All right, so my clock is saying 30, and that turned green. So we're ready to get started. Welcome, everyone, and thank you so much for attending or tuning in to our session here today at Microsoft Ignite 2018. This is real-world data movement and orchestration patterns using Azure Data Factory. My name is Katrine Wilhelmsen, or Catherine Wilhelmsen. I'm from Norway. I work as a senior business intelligence consultant in a Norwegian company called Inmeta. And you can find me on Twitter at Catherine W. Just please note that there's no E in the middle of my name. That's a funny Scandinavian spelling.
And I'm Jason Horner. I'm a practice lead with a Microsoft partner by the name of Tunix. And let's get to it.
Let's get to it. So in this session today, we're going to cover three main topics. So the first one is an overview of Azure Data Factory, the key concepts and what's new in V2. Then we're going to dive into the main part of our session today, which are the actual design patterns in Azure Data Factory. And finally, we're going to show you a little sneak peek of something. You may have seen this already, but we're going to save that for the end.
You mean there's more new stuff?
There's more new stuff.
There's always more new stuff at Ignite, guys, huh?
So let's start with an overview of Azure Data Factory. Azure Data Factory is a data integration tool, hybrid, cloud, and you can use it for all sorts of fun things. The main thing that you might use it for is moving data from a source to a destination. So for example, you can use Azure Data Factory to ingest data from blob storage into a SQL data warehouse. You can also use it to process analysis services, and then the output of that will be used for reporting, but the reporting part is outside of the actual data factory itself.
Now, even though we can use it to do a traditional kind of ETL load for a data warehouse, it also supports big data pipelines and engineering, so you can run this to orchestrate your HD Insight jobs or your Azure Databricks jobs as well. And it also connects to Azure Machine Learning. So you could bring data in from Azure Blob Storage, prep it, and then put it back into Azure Machine Learning Services.
It's just a few quick notes on what's new in Azure Data Factory V2. First of all, they have a visual UI now. So it's web-based, so you do all of this in your browser, and it's all drag and drop. It's a lot easier to work with if you're new than the previous versions that were all code. If you like code, however, you can still do that. So it supports several languages, so you can use the one that you prefer. They also have these control flow capabilities, so you can do things like looping, branching, if-else, and kind of have a little more control than the previous pipelines that were more sequential. And finally, you can also lift and shift your existing SSIS packages into Azure Data Factory to execute them there.
Now, one of the interesting things, how many people here are familiar with SSIS as an ETL tool? Okay, great. And one of the great features of SSIS is its use of XML to store its code, right? Because it's very easy to difference and it's very easy to store in source control. Well, what's nice about Azure Data Factory is they're using JSON, which is my favorite programming technology, because of course I am JSON as well. I would like to say I'm JSON V2 though, so I'm a little bit more approved. But the key point there is that we can use these tools like Python or any other code to generate the JSON files and publish them in there. So we aren't stuck with just that visual UI experience in the browser. Now, one of the kind of things that people aren't as happy with in V2 is there's no Visual Studio support like you had for V1. So just be aware that the browser-based experience is kind of the GUI kind of moving forward. But there's a lot of activity on the feedback site. So it's probably, I'd say, the most requested feature is to add support into Visual Studio. So if you want to get that support, definitely send that feedback back to the product team.
All right, and then Azure Data Factory can be used for both ETL and ELT. So what is that? What's the difference between those two? Just a quick overview on that. So starting with ETL, it's extract, transform, and load. And basically how this works is you have a bunch of sources that you extract. Then you transform them, and this could be something like remodeling into a dimensional model or something similar. And then you load that, and then the output of that can be used for reporting or analytics. The other part is ELT, extract, load, transform. So it's very different. We're switching a word around there. Same thing, we start with the extract, but then we do the load process. And this is more kind of a replication. You just load data from A to B without doing anything in between. And then once you've loaded that into the destination is when you actually do the transformation itself. So this is being done on the destination side of it. Again, you can use that for reporting and analytical purposes. And to kind of Compare these two, you can see they're similar but different. And ETL is what we know from SSIS. So this is where we do everything in memory, in the data flow. So everything is in memory, the transformations and all of that. While Azure Data Factory is more on the ELT side, where you just load data and then you have to use a different type of service for the transformation.
Yeah, now one of the important things to understand, since this is a design pattern session, and we'll show no code today, it'll all be just architectural, ivory tower type stuff, but why would we use ETL versus ELT? So ETL obviously gives us the ability to transform the data in memory, but there's scalability limits. So if you want to use an MPP technology, then ELT, move that large volume of data, stage it, and then operate it on in place with compute activities, such as Azure Databricks or HD Insight. Now, SSIS does support scale-out in the latest version, so there's some scale-out, but you can't scale out a single pipeline. You can scale out multiple packages across multiple nodes, but there's no ability to scale up, so you're effectively compute-bound on a data flow, if that makes sense.
And over to some of the Azure Data Factory concepts, just to give you an outline of what we're going to walk you through here today. So the most important thing in Azure Data Factory are the pipelines. So an Azure Data Factory can consist of one or more pipelines. And inside of these pipelines, we have different activities. So on activities, they are being grouped and they are made to perform a single task. So this could be ingesting data and loading it into a data warehouse, for example.
So one of the key things for those of you who are familiar with traditional SSIS, a pipeline is very similar to a package. However, it only has control flow. It doesn't really have the concept of a data flow.
When you have those activities, you need to connect to your sources, and by doing that, you're using linked services. So you can think of linked services as connection strings. There are two types of linked services. You have the data store and you have the compute activities. So data store is more for databases, file storage, as the name implies, where you store data. And then the compute activities like HD Insights or Databricks.
Now, what's really great about Azure Data Factory is there's over 65 connectors that can connect a variety of data sources. So these can be things like our traditional on-prem relational database stores, even MPP appliances such as Teradata. It can connect to IaaS services. So if you've got VMs or EC2 in AWS, you can connect to those SQL or Oracle instances, whichever you prefer. We hope you prefer SQL in general. And then it also supports SaaS services, so like Marketo and SAP and Salesforce. So you have a lot of connection opportunities. Just like Ignite, you have a lot of opportunities to get connected with Azure Data Factory.
Then the third part here are the data sets themselves. And these data sets are just representations of your data. So this could be representing a table or a single file.
One of the things that to understand about data sets is that they come in two flavors. There's structured, which is very similar to the traditional SSIS data sets, where you have very tight coupling to the metadata. So if everybody's familiar with, oh, I changed the SQL query, now I got a bunch of squiggly lines and broken packages, that's more like akin to the structured data sets. But what's so powerful about Azure Data Factory V2 is the ability to leverage non-structured data sets, where it just says, I'll take whatever you give me, and I'll just assume that this is the data you want to move forward. And that's very powerful and enables a lot of our patterns, as you'll see.
And once you have all of these pipelines with your activities to perform a task, you can execute them in multiple ways. One is doing it just on demand when you want to execute a pipeline, but there are also triggers. So you can set up triggers. And for those of you familiar with Azure Data Factory V1, you'll be very familiar with the tumbling window type of execution, where you have these little time slices that you're working with. In Azure Data Factory V2, you also have event-based and scheduled triggers.
So scheduled triggers are very similar to what you have with like a cron or a Windows scheduling service or even a SQL agent. So all those kind of capabilities to specify the cadence and the actual execution time is available there. The event-based trigger right now can detect either the creation or deletion of a blob in Windows Azure Blob Storage. And it can basically determine to a path in that container, right? So I can look for a specific path, and that's really critical for instrumenting kind of these big data pipelines where you're ingesting into kind of a data lake pattern. You have a file that gets generated by some other process, and you're monitoring for the arrival of that or the removal of it. So you can kind of use that as a poor man's messaging bus.
And the last part of this are the different integration runtimes. So you can have self-hosted, private, you can have an Azure, public, and you also have this SSIS Azure that you can use for, or Azure SSIS, for when you lift and shift your SSIS packages into the cloud and execute them there.
So what's very important to understand is the Azure Data Factory itself can live in an Azure region, for example, East US. However, the integration runtimes can actually live in different regions, or they can live in your on-premise environment. And so why that's important is the actual data and the compute flows between two integration runtimes or within a single integration runtime, and they use a concept called data integration units to determine how much CPU and the performance characteristics. That also is related to how much you'll be billed for the service. But none of the data goes back up into the data factory. The data factory is just a metadata store for these JSON files.
All right, let's get into the most important part of the session today, the Azure Data Factory design patterns. So what are design patterns?
So design patterns are basically common tested solutions for solving specific problems. They're very important, but it's important also to note that it's not like a snippet, right? It's not like you just drag and drop this on and you have a completed solution. It's all about your approach. How are you going to approach a problem?
And why would you want to use design patterns?
So they speed up development, they improve code readability and consistency, which also facilitates better testing.
All right, and today we're going to go through 4 design patterns. Like we said, it's a 45-minute session, so we can't cover everything, but we're going to cover these 4 today. First, truncate and load. Then we're going to move on to merge load, incremental load, and finally bulk table transfer. So the first one, truncate and load.
So in the truncate and load, we're basically just doing a destructive copy, basically. So we're pulling all the data from the source system. We first truncate or remove the data in the target system, and then we move the data via copy activity. And it's important to note again that the integration runtimes will determine where that compute executes at.
And the architecture for that looks something like this. So on the left side there, you'll see the sources, like Jason said, with the integration runtime little icon down there. So you have a source table, and you want to move that over to your sink, your destination, your sink table. And that is going through the copy activity in the pipeline.
Yep.
Then we have merge load.
So the merge load is a pattern that we're going to use when we need to make sure that we're not causing a bunch of churn in the staging environment, right? So we need to not only support inserts, but we need to support updates and perhaps deletes as well. And so this pattern adds a little bit more complexity. So what we're doing is we're still using a copy activity. And we can go to the next slide. And what we're going to do is we're going to use that copy activity. We're going to select all the data from the source table, or all the data. We're going to move it into a user-defined table type within SQL Server, potentially. And we're going to populate that as a DTO, or a data transfer object. And then we're going to pass that into a stored procedure. The stored procedure is actually going to do the work of copying the data to the sync table. Now, an interesting thing to understand here is that earlier I said there's no kind of concept of a data flow inside of Azure Data Factory, but if we use this pattern, we can actually perform our enrichment and our cleansing inside that stored procedure as well. One of the key things that we have to comply with, though, is that the schema of the source table, or whatever queries we're bringing in, whether we're using a select star or picking specific columns, that has to match the naming and the case of that table data type. Otherwise, the mapping won't work and you'll get an error.
So for both truncate and load and merge load, there's still full extracts where we have to pull all the data from the source. Can be considered an anti-pattern. So the next step is turning that into maybe an incremental load.
So the incremental load is a pattern that we're going to use when we want to minimize the weight on the source system, right? So we're going to rely on perhaps a trigger with the last modified or a high watermark column. Or we may rely on engine features. In SQL Server, we can rely on SQL Server change tracking or change data capture to only identify the rows that have been inserted, updated, or deleted. And that's a very efficient way to do delta detection and incremental load of large data sets that may have many changes.
And the architecture, as you see, is similar, but we now have a few more things, especially in the Azure Data Factory pipeline itself. So you can see we have a couple of lookups there, and we have a copy data activity, and finally a stored procedure. And we'll walk you through this in the demo in just a little bit. And then we also have a few more things in the source and the sink.
That's correct. So in addition to the kind of change tracking functions that we use to identify these new rows, we also now have to maintain a stateful table in the staging database that stores the information of the last time we extracted, so we know what to go back over, right? There's multiple ways to do this, but we still have that DTO with the table type. It still needs to match. We get some additional metadata columns coming over from the change tracking tables, and then we load the sync table with the stored procedure.
And one of the most important things to do in an incremental load is to detect the deltas, or to kind of find the data that has been changed. And there are a couple of different ways to do that.
So delta detection is really about detecting changes, right? Now we can use a lot of different techniques to do that. We can use SQL Server's built-in hash bytes function to do a hash comparison instead of a column-wise comparison. We can use a high watermark, which I've talked about a couple times now. That's simply just a column, either like a last updated, or maybe we have a log table where we're only inserting data, and it has a sequential ID, so that's the last value there. And then, of course, we can use the traditional change tracking tables. Now, as far as delta detection, we need a lightweight solution, and that's really what SQL Server change tracking gives you. It's a synchronous change, so when you turn on change tracking, you basically incur the weight of roughly an additional non-clustered index, but it gives you the ability to say, okay, this row has changed, and by the way, it's an insert, or it's an update, it's a delete, so it sorts that all out for you, and it adds some additional metadata as well. The one problem with it is it only tracks the latest change to a row, so if a column gets updated multiple times throughout the day, you're only going to get the most recent change, right?
The last pattern that we want to go through is the bulk table transfer.
So the bulk table transfer is very powerful. In SSIS, traditionally what we've had to do is we've had to build a package per table that we want to move, right? Or we rely on some other solution like BIML or something like that to generate the packages. But best practice is usually one package per data flow. With bulk table transfer, I can store all this data in a control table and just iterate over it. And because I don't have strongly typed metadata under the hood for the data sets, I can just iterate through those tables and run them through a copy activity. So it minimizes the code in the solution, and it enforces kind of a similar loading pattern for all tables. So there's lots of consistency. And it scales anywhere from 10 to thousands of tables.
And what you can see here is it's a little similar to the incremental load in the actual pipeline with a couple of lookups. But then instead of having the copy data activity and the stored procedure in there, we have a for each task, and then we're executing a different pipeline like Jason mentioned.
Yep. So we've added two additional things. So we have that control table that maintains our state, but now we're also tracking a log table. And the log table is really critical because even though Azure Data Factory can store data to Azure Monitor or can pass logging data to Log Analytics or to an Event Hub, you want to track that unit of work as a batch. Like if I go in and extract all the data from EventWorks, I want to make sure that I've got all of them successful before I declare everything good and move on. And so that logging table gives me the analytics behind it. It tells me how many rows I've inserted, how many I've updated, how many I've deleted, and it also tells me whether the status was successful or not. Which kind of brings us to the concept of batches. So usually every ETL process should start off by assigning a unique batch ID, and this is the ID that we're going to group that entire unit of work. And this is critical for tracking the operational metadata and lineage, and it helps drive any dashboards that we would want to build for the ETL process. And usually what we do is when a batch executes successfully, we'll close it, and the next time we run, we start a new batch. Or if it fails, we troubleshoot it and start a new batch, and finally it succeeds. One of the key things we want to do in a well-oiled ETL solution is we want to store common auditing columns in each of the tables. And this is kind of what we kind of recommend. We want to audit the creation date, the create batch ID, which batch ID is updated or inserted this data. We'll store the modification information, and then potentially a is deleted flag to identify when data's been deleted.
And then outside of the auditing, we also have the logging itself. So we want to log the row counts for selected, inserted, modified, ignored rows, maybe even more. Execution time, so begin and then duration, and like we've mentioned a couple of times here, the load status itself. So that brings us into the demo. So we'll switch over here. Let's see if we can get this working.
All right, so Catherine's going to take over the telestrator while I walk us through the demos.
There we go.
Any questions so far? Is everybody good with that? Was that a good, for people who haven't seen Azure Data Factory, do you guys feel like it was a good overview? I know it's kind of fast. Okay. All right, so what we have here, this is the browser-based experience, the GUI for Azure Data Factory. Now you can launch this by going to adf.azure.com, and it'll prompt you for your login information, your subscription ID, the name and the name of the data factory. Now, I've got this inside of a Chrome browser, but it's an application shortcut, so I've minimized all the browser-based stuff, so we just see it kind of like a visual application. And so what we can do is kind of do a quick tour of the UI. So, Catherine, do you want to click the little signs, the little less than signs over there? Now, if you happen to get into the wrong data factory and you want to switch to another one, you can switch it down there. And also note that it tells us the region and the resource group that's associated with the Azure Data Factory. So that's useful information. It's a little bit hidden by default, so I like to call that out to people. I also like to show you guys a couple features that you might overlook in the top ribbon there. We have an RSS feed icon. Now, every time the Azure Data Factory team posts an update, they're pretty good about blogging it. So if you want to see, like even today, I think I saw some new features from the last time I tested it. So if you want to see new features kind of come in, they usually are pretty good about blogging it. If by some crazy chance they find a bug in the tool or something that makes you unhappy, you can take your vengeance out on Microsoft by either giving them a frown or a happy face, sending them your email. They won't send you marketing, I promise, and then write some comments. Now, you probably won't get a response to this, but it gives them the telemetry about, hey, something's going wrong in this latest version. So what I usually do, if I encounter something that's bad, I'll send one of these, and then I log into the Azure portal and actually file a support case if it's something that I can't resolve, like it's not a user error. So that's the feedback. And then the other thing that I like that's kind of cool is a little question mark sign. It's a quick link to the documentation, because I get sick of typing the documentation link, so that'll get us quick into the documentation. Okay. Now, you'll notice over here on the left-hand nav, we've got all of our different resources. So we've got our pipelines. And one of the key things that I don't think people do in bigger production solutions is leverage these folders, right? So the folders are used to organize the solution and keep everything nice and tidy. If we look at the data sets there, you'll notice that we've got some data sets and we can leverage folders there. Now, for our bulk table transfer, we're only using 2 data sets, right? Because we're very loosely bound to that metadata. And if we actually open one of those data sets and we go to the parameters, you'll see that I can actually parameterize the table name that that data set is accessing, okay? And if we click the code icon up there, this is kind of new, so for those of you guys may not have seen it for a while. It used to be this was just read-only, but now we have full editing capability. So I can work with the JSON if there's something I can't achieve in the GUI. So it's very important as you guys are working with these different types of objects to read the documentation and understand all of the options and properties, because sometimes certain options aren't always exposed via the GUI, or sometimes you may want to parameterize something with an Azure Data Factory expression that isn't supported in the GUI, but you can do it through here. So this is an important way to get out of it. And also, sometimes it's not efficient to go through and add 10 parameters to this, but I can copy and paste that JSON right into the code window and I can reorder it. So there's a lot more robust editing capabilities in here in some cases. Okay, so that's the data sets. And then if we go down, we can see all of our connections. So I've set up all these connections. We can look at the staging connection. We can click edit. Now, one of the key things that I've done here that I think is a security best practice is I've used the managed service identity. What a managed service identity is it's a GUID that's associated specifically with that Azure Data Factory instance. And then I can assign that GUID to an Azure Active Directory security group, and I can hang permissions to resources off that Azure Active Directory security group. So there's no password to manage. It's very secure. And you have other options like Service Principal or an Azure Active Directory app registration where I can create a kind of a service account with a key. All of those credential informations will be encrypted inside of Azure Data Factory, but I can add another layer of security on top of that by using Azure Key Vault Store. Is anybody using Azure Key Vault Store today? Okay, good. So there's a few people that care about security. That's always good. And then I have SQL authentication, right? Now, obviously, this is a linked service for Azure SQL database, so the different linked services will have different levels of support. Like one of the things I think I read recently is they just lit up support for managed service identity authentication with blob storage. Prior to that, I think the only option you had was Service Principal. So that's kind of how linked servers work. Now, oh, sorry, Catherine, can you go back just real quick? a couple other things to kind of take note of if we scroll down a little bit. You can add user-defined properties to pass things through, and then you can add annotations. So those are just ways of adding name value kind of metadata that can show up in the logs. And that's useful for larger solutions where you kind of want to get a little bit more information in the log directly as opposed to having to dig through all the JSON. Okay. So now we've looked at the connections. Let's just take a quick look at the trigger. We've got one trigger set up, so we can just open that code real quick. So this is the scheduled trigger, so it's just wall clock. You can see I can set the reoccurrence. I've got lots of options underneath that. I can set the start date, and I can start the specific hours and minutes of day that it activates, and I can make it either activated or not. Okay. One of the other things to note is all these times are in UTC, right? Okay. And now if we go real quickly to the monitoring console, there's a GUI monitoring here, which is pretty nice. So it gives us all information. Now, we haven't run anything in the last 24 hours, but if I click that dropdown, or if Catherine clicks the dropdown, we can change it and say, show me everything in the last 30 days. Okay. Now, I had to work really hard to get all these errors to show up because I don't make a lot of mistakes. But notice it sends all my data that I have. So I've got my annotations. If I click on the annotations, if there were annotations, it would show up, right? So I don't have annotation. I've got a couple in there. The parameters, I can click in that and see which parameters actually ran. So that's very useful, right? I can tell how it was triggered. Was it manual or scheduled? I can get the duration and when the runs start. And I can restart it with the little arrow, or I can click on the other box, or the pipe, I guess. And now I can see which activities actually ran in that context of that pipeline. I can see in the actions, I can see the inputs into the activity, so I can see exactly what went in there. So there's a truncate statement, it looks like. I can see the outputs. Okay, what did I do? So summarizes the copy duration, number of rows, so on and so forth. And then I can use the glasses icon to see an overall summary. Now this is really powerful because this is going to help me tune my ETL pipelines, right? Because I can see not only how much data went through, because that's one of the cost drivers of Azure Data Factory, but I can also see the number of rows, okay? And then finally, one thing that we can see if we scroll all the way over to the right is the user properties. So this feature is lightly documented, but basically what I do is on the activities, and we'll show this when we get into the demo, I create these user properties and then I can look at them directly in the log. So when those are turned on, we now see that we have source and destination show up directly in the log, right? Now, that information is also in the JSON, but it's kind of promoted to a first-class citizen. Does that make sense? Are people aware of the user properties? Anybody using them today? Wow, okay. So you guys learned something, so you can all leave now. I'm just kidding. So let's go into one of the pipeline patterns. So we're looking at the truncate and load pattern. And the first thing I want to show you guys is the concept of parameters. So pipelines can take parameters, and you can see I've parameterized all my configurable elements such that I could run this for the customer table, or I could run it from the product table. So that's all driven. And the benefit of that is it makes it very testable, right? I can interactively develop, I can change values, and I can execute it and get it to go. If we go over to the sync on the copy, or the source on the copy activity, now you notice here's where all my parameters come into play. So what I'm doing here is I'm using the Azure Data Factory expressions language to say, from the pipeline object, give me the parameters collection and give me the source table name from that. And same thing for the source reader query. So what I've done is I said, okay, the source table name is customer, and the query is select star from customer, okay? And now, the reason we do that as opposed to hooking up to the table is it gives me a little more control over what columns do I care about. I could also execute it as a stored procedure, okay? If I go over to the sync, I can see that I've done the same parameterization there. I'm also using a pre-copy script. So what that gives me is the ability to truncate that table before I load it. So that works when the target table is my final destination. It also works if I want to have a transient staging table. So if I kind of want to do that, copy the data to a transient staging table, and then merge it into another table, I can choose that option as well. Okay? Notice I don't specify a stored procedure name, but I do specify a write batch size. The default for the write batch size, if it's not specified, is 10,000 rows. The reason that's important is because that's kind of the unit of commit that SQL Server or the data source will use. It'll write it in batches of 10,000 rows. Okay? And then we can go see where the user properties are defined here. So every copy activity should have a user properties tab. Some of them will support this auto-generate notion where it'll automatically pick up on the properties that it thinks you care about, but I can always add my own custom ones. And I can either specify hard-coded text there, or I can use Azure Data Factory expressions. Okay? So if we look at that, that's basically the truncate and load pattern. It's very simple. Now I could put auditing stored procedures in front of that and behind that, but that's the crux of it, right? So it's a very simple load pattern. Now if we look into the merge load, we're going to add a little bit more complexity. And the main difference here is on the sync. So if we look at the sync, what we've done is we've specified we no longer have a pre-copy script because we don't need to truncate. Now we still could run a pre-copy if there was something we needed to do, perhaps in the staging environment to kind of clean things up or whatever, but we're not doing that here. We do have this stored procedure, okay, if we scroll down a little bit. You notice that we can pass in parameters as well, so any parameters I want. So here what I'm doing is I'm specifying all these parameters to kind of add information in the stored procedure for logging and auditing, right? So there's a lot of robust information there, and I'm using pipeline expressions to pass those values, okay? And then I've got my write batch size. And the one thing that I skipped over, so if we go about midway up there, Catherine, is the table type. So this is critical. This is where we define the name of that DTO, and SQL Server is going to pass that object over for us, okay? And if we look at let's look at the actual SQL code behind that one. So here's a definition. How many people are familiar with the user-defined table types in SQL Server? Okay. So one of the problems with user-defined table types, just to be aware of, is that they don't maintain very good statistics on them. So if you have a very complex source query, you might want to change the way you might want to add a query hint to your selection query. But what we're doing here is we're matching exactly the casing as well as the data types and the nullability of the source system. And then if we scroll down a little bit, we're also defining a primary key. So that's critical because that'll help us know which columns to join on, and it'll give that information to the query estimator when we look at the stored procedure later. And if we scroll down a little bit more. So here's our stored procedure. Now the key thing here, aside from these metadata columns, if I scroll down to the end of the parameter list, is you see I'm passing that source as sales LT customer type as read-only, right? So that means SQL Server knows that that table's not going to be modified. I can't insert or update data in there. So if I go into the body of the stored procedure, I'm using the merge statement. Now, a lot of people don't like the merge statement, so you could do this as an insert or update, but notice my using clause. My using clause is selecting star from source, so that's my table data type that I've passed in, okay? Now, and I'm also creating the hash using the SQL Server hash bytes function, okay? So I could do that here like I'm doing it, or I could create that hash in my source reader query. That's just kind of an implementation detail. And then notice my join clause. So I'm joining on that primary key. If I had multiple column composite primary keys, I would add multiple join conditions. And then I'm also saying, oh, and by the way, the change hash key has to be the same. So the data that I loaded or they don't need to be the same, right? There has to be a change. Otherwise, if it's a no-op, I don't want to update for no reason. And then I've just got a standard SQL Server update statement. And then I've got a kind of novel thing here where I'm inserting the data when there's no match on the primary key. Obviously, that's a new value, so I'm going to insert it. But I'm also using the output function to dump the rows into a merge summary. And then I got my row counts from querying that merge summary table. So I can figure out how many rows were inserted, based on the action type, right, and determine how many rows were updated, okay? And then I could take the results of that and pass that into my auditing stored procedure to say, okay, this stored procedure ran, I updated these rows. Now what's interesting is based on the write batch size, if I have 100,000 rows and my write batch size is 10,000 times, how many times is the pre-query going to run? Once if I specify it, right? How many times is the stored procedure going to run? 10. Right? So it's going to run multiple times. So I need to make sure that those audit logs are reentrant, that I can call them multiple times and it'll do the right thing. It won't just update the log entry. It'll look for the current log entry and add the counts so the numbers come out correct. And then if we go down to the bottom of the Sprock, I'm doing some rudimentary error handling, not much there, but I could make that a lot more robust. Okay? So that's the merge pattern. Let's go ahead and take a look at the incremental load pattern. All right. So the incremental load pattern is a lot more complex. And I want to focus on the last high watermark lookup activity. Let's look at that. If we go to the settings there, the key thing that we're doing here is if we scroll down past the query, see how I've checked first row only? That means that there's a contract that says this query is only going to return one row. Okay? And it turns out that that's going to be very important in the copy activity. If I go look at that copy activity, okay, and I go to the source, I'll scroll down a little bit, notice that that activity and the last high watermark, so it says, okay, find the activity with the last high watermark, call output.firstRow, so it says I'm getting a data set with just a first row, and then give me the sync stored procedure name column. So that's how all that metadata is being driven externally from those lookup activities. So let's actually look at the actual mechanics of the change tracking process inside of SQL Server. So to set up change tracking, one really good thing to understand about change tracking is that it's supported in Azure SQL DB as well as in SQL Server Editions, Standard, Enterprise, so on and so forth. So change data capture, for example, it's a little bit more complex, a little more robust, but it's not supported on Azure SQL DB. So that's why I prefer change tracking. I alter the database, I set the change tracking on, and then I go in and at the table level and I have to enable each table for change tracking, and then I can choose whether I want to track the columns updated in a bitmask or not, okay? Now, on the source database, what I'll do is I'll run these change tracking functions in a query, and I'll say, so this is my first lookup, and what that's going to do is it's going to return the current sync version, and it's going to return the min valid version. Now, what min valid version says is for this object, what's the minimum level that you need to be at before the drift has been too much that you've got to reinitialize and go do a full extract again. So it's very similar to how a replication may need to be re-snapshotted, okay? And if we scroll down a little bit more, I've got a user-defined function. This one's interesting. We'll actually run this one. So you can see all of my rich metadata here for the table name, sync table type, and if I go over to the far right, I see my watermark information. I've generated my select statement. I've generated my truncate statement. And oh, by the way, it's an incremental. So I'm going to actually run that initial load query. If I had already processed things in the watermark, I would have generated a different query that will do an incremental load or full load. If I look below, this is the key thing for the initial load query, is I actually cross-apply the source table with the change table. So that's a change tracking table. I'd say, okay, here's my primary key and here's my table, and I get the version for that. Now, to keep the metadata consistent, I've kind of had to fake it out on lines 57 and 58 here. So I've actually used since there's no syschange creation version populated, since this is initial load, I just say, oh, it's a syschange version, which is the same thing. And oh, by the way, it's an insert, so it's an I change operation. And then I get the change context, okay? Now, the incremental load query, I actually have those values populated because we're doing an incremental load, so I know when the row was created, and I know what the current version is, I know what the operation is, and I have the context. The query is a little bit more complicated because I'm left out or joining to the customer table, and then I'm basically saying, give me everything from the current version, so the version that I extracted, which is 1 here in the change table, the last version that I extracted, which is 1. So what I'm saying here is the last version that I extracted and saved from my stage was 1. And if I scroll over to the right, I can see that I'm currently on version 10. Now that version 10 will be global for the entire database, but the min valid version will be tied to a table, okay, as well as the last version, okay. So if we scroll down a little bit, I think we have some more code. So this just shows that the table type has changed slightly. So if I look, here's the table types that I've added for this system change tracking. And then the stored procedure is very similar, but we can look through it real quick. So same information going in. The only difference is we've modified the insert and update statements in the merge itself, right? So we've added the change tracking tables, same stuff going on there. So that's our incremental load pattern. And the last pattern we're going to look at today is the bulk table transfer. Okay, so with the bulk table transfer, all we're doing that's different is we're assigning a batch ID, we're getting a list of tables, right? So if we go to SQL real quick, Catherine, and we can run that query, the driver query. Yep. So now here's our list of tables, right? And we have the table data type that we need to pass in. We have the sync table name. We have the stored procedure. And if we scroll over to the far right, in the result window, sorry.
Excuse me?
We also can set the sync write batch size, and we've got some other things about what load type is it active, so on and so forth. So I can use that to filter only the active tables if I was doing debugging or whatever. Now, if we go back to the GUI environment for Azure Data Factory, and we go into the Get Tables, and then the settings, what we'll see over there is we'll see that we've unchecked the first row only because we want to get an array of tables back, right? We want a JSON array of tables. And if we look in the Load Each tab and go to the settings there, go to settings first. Now look at the items is the activity name get tables output.value, so that populates the items collection. And now if we go to the activities, here's where I could chain activities. Now if I edit those activities, most people would be inclined just to reduplicate all that pipeline copy. So if I was going to do a stored procedure call and then a copy activity, but what we've done here is we've used the execute pipeline job to encapsulate all that logic so that if I wanted to test this in isolation, I have that capability. So I'm just passing the values from those metadata parameters into the pipeline. So how many people have used that pattern or have seen that before? So this is new for everybody? Maybe a couple people have seen it? Okay, cool. So those are really our 4 key patterns. So what are really the key takeaways here? So the key takeaway, number 1, is get the metadata model correctly. What I've done is I've actually used T-SQL to generate a lot of those statements and object types. I could actually have done all that work or a lot of that work inside of Azure Data Factory with Azure Data Factory expression language, but to me it's easier to test that SQL query outside of Azure Data Factory and validate it. So as long as we have the metadata stored in the formats that we need and we understand what metadata we need to put in, it's very easy to use Azure Data Factory as a driver process, right?
So a bit of a whirlwind tour on design patterns there for you. All of this code, the demos, the slides will be available afterwards. So if there's anything you want to dig into, just let us know. The last 3.5 minutes here now, I promised you a little sneak peek of something. So all of the design patterns that we've looked at here today is based on the current version of Azure Data Factory V2. There is something coming up, though, that might change some of these things that you should be aware of, and that is data flows. So far what you've seen is that we only have control flows in Azure Data Factory, but they're actually building in data flow, and this is currently in private preview. So if you log into the Azure Data Factory portal now, you'll see a little ribbon up top that says if you want to join the private preview program, go ahead and do that. So Azure Data Factory data flows, very cool feature. It's visual authoring, so it's the same interface that you recognize from what you've seen so far. You can drag and drop to do all of these little data flow transformations inside of Azure Data Factory. And all of this runs on Azure Databricks, so you're actually merging a couple of different technologies together here. But you don't need to learn Databricks. You don't need to know the details of it. You don't really need to know anything about it, and you definitely don't need to learn Scala and all the code that you run in there. It's all visual, and it's taking care of all of that for you. And you can do all of these transformations at scale, things that you recognize from SSIS, joins and splits, aggregations, lookups, filters, sort, all of these different transformations. So that can kind of move some of that logic out from the stored procedures where you might have it with the design patterns that we showed into these data flows instead. And what this looks like is something like this. I know this might be a little small on the screen, but on the left side there, you will see you have some thick blue lines. That indicates that these are your sources, and then this is going from left to right. So on the right side, you'll see the blue lines again. Those are your sinks. And in between, you have the different transformations. So you can look at this slide and look into the details and go ahead and join the private preview and give some feedback to the product teams and see how you can use this to get those transformations into Azure Data Factory.
Good stuff.
And since we only have a minute and a half left, and I know it's late for all of you, we're going to skip the little demo part here. Basically, what I would show was what was in the previous screenshot, just to show the UI, show you a little couple of drag and drop features in there. I'm sure you can imagine it based on the rest of the UI. So I think that's it for us today. We will be here for a little bit longer if you have any questions. And then I know that you're probably all ready for some food and drinks. So the expo hall is open now with the little expo social hour. Let us know if you have any questions. Email us, tag us on Twitter, and we hope you enjoy the rest of your Microsoft day.
Skip to the next screen.
Oh, okay, that one?
Yeah, so if you like this session, then fill out the feedback. If you didn't like the session, this was Buck Woody and Azure artificial intelligence insights, right? No? Okay. That doesn't work?
Yeah.
Okay.
Doesn't work that way. They scan you on the way in.
Oh, man. Okay, so you have to be honest. But definitely give us feedback. Catherine likes feedback. I just ignore it and go to Universal Studios. And
I like to improve, so I like feedback on how we can do better.
But we both like to move it, right?
We do.
Because that's Azure Data Factory likes to move it.
So please give us feedback. We're here if you have any questions. Contact us if there's anything, and enjoy the rest of Ignite.
Yeah.
Thank
This
you.
is the part where you guys clap.